3.4 properties of logarithmic functions. So we've got the product rule, which is the log of a product is equal to the sum of the logs. We have a quotient rule, log of a quotient is equal to the difference of logs. And then we have the power rule, which is throw it out front. So these ones say to use property of logarithms to write the expression as a sum or difference of logarithms or multiple logarithms. So number 2, got ln of 9 times y. So this is multiplying. So when we're multiplying, there's one log written there. When we go to do the sum of logs, we're going to have 2 separate logs. So this will become the ln of 9 plus the ln of y. Now, some people will take this problem farther, okay, because the ln of 9 is technically a number. We could rewrite this as, now, I'm just going to tell you, I would be fine with you leaving it here, but I'm going to show you how the book continues it on farther, just so that you're aware, in case this happens in another problem. But they would rewrite this as the ln of 3 squared plus the ln of y, and then throw this 2 out front for the power, so 2 ln of 3 plus the ln of y. I would take your answer either way, okay? Personally, I would have just left it here, but the book continues on and takes it all the way to 2 ln of 3 plus the ln of y with their answer. Now, obviously, if it was like x to a power or something like that, we would need to put it out front. But I'm not expecting you to rewrite, 9 as 3 squared and keep going. If you want to, totally fine, not required. 4, log of 2 over y. So this is a quotient, so that means I will be subtracting. So it's always top minus bottom. So log of 2 minus the log of y. And that's all you have to do for that one. There's nothing else I can do with it. 6, log base 2 of x to the negative 2. So in these previous two, we've had a natural log and a common log, so there's been no base associated with it. If there was, then when I did the splitting, I have to make sure I keep the base with it. So what rule is happening with this one? The power rule. So I'm going to throw that negative 2 out front. So this is going to become negative 2 log base 2 of x. And that's all you have to do with that one. Um, 12. Ln of the cube root of x over the cube root of y. So this one's a little different because I've got cube roots in there and I've also got a quotient. So I would go ahead and, well, first of all, what I would do is I would rewrite the cube root of x in a different form. What other way can I rewrite a cube root? Yep. So I can rewrite them to the power of 1/3. So I'm going to rewrite this as ln of x to the 1/3 over y to the 1/3. Now I'm going to split these into their 2 separate logs. So it's a quotient, so I'm subtracting, remember, top minus bottom. So ln of x to the 1/3 minus the ln of y to the 1/3. Now I can throw the 1/3 out front. So I end up with 1/3 ln of x minus 1/3 ln of y. Then both of these pieces have a 1/3, so I'm going to factor out a 1/3. So I'm going to have 1/3 ln, oh, let me do this. 1/3 times the ln of x minus the ln of y. And so this would be the correct answer here with it all factored out. Any questions on those ones where we're splitting it up? All right. So now we're going to go the opposite way. These say use properties of logs to write the expression as a single logarithm. So these ones you're going to have multiple things and we are combining it into one log. So 14 log of x plus log of 5. So log of a product is equal to the sum of the logs. You can say it backwards too. You know, sum of the logs is equal to the log of a product. So I take these two things and I'm going to be multiplying them. So this is going to be log of 5x. So notice it's one single logarithm with the stuff multiplied together. 16 ln of x minus the ln of y. So this is, again, where it's critical to remember that when we are subtracting logs, it's always top minus bottom. So one log here, this is ln of x minus y, so, or, well, you know what I mean. So x divided by y, because it's the first one on the top, so x over y. If they give you one like 18, where it is 1/5 log of z, mixing up the letters on us here. So a power rule, I'm going to throw this back onto the z. So I would get log of z to the 1/5. If you left it there, I don't care. The book is going to take it and go log of the 5th root of z. But I will take it either way that you leave it. Thank you. That way I'll know I can actually give those back tomorrow. All right, 20. 4 log of y minus log of z. So what do I need to do with this one? Or like, what's the first thing I should do?
Throw the power.
Yep, throw the power. So log of y to the 4th minus log of z. Now what? Yep, so I'm going to have one single log of y to the 4th over z. Make sure I can read this 4 here. There we go. All right, one more that is a little bit more in depth. 3 ln of x cubed y plus 2 ln of yz squared. So it's interesting, they actually had not divided this one all the way up to begin with, which is nice because if they had, that would be a lot more for us to deal with. So remember trying to make it one single log, so what would the first thing that I need to do be? I'm going to put the powers up here. So I'm going to have the ln of x cubed y raised to the 3rd plus the ln of yz squared. Now what? Multiply the powers, yep. So I'm going to end up with ln of, when I do this 3 on here, this is going to be x to the 9th y cubed plus ln of y squared z to the 4th. And finally, what do I need to do? Combine them by multiplication. So I'm going to have ln of x to the 9th. Now, both of these have a y in them. So y cubed times y squared would be y to the 5th. And then z to the 4th. So that would be it fully combined. Any questions on combining? All right, the last thing, I never remember if it was in your notes or not. Do you have the change of base formula in your notes? Mm-hmm. Okay, beautiful. I think I had like gone back and added it because some years I do it later and some years I don't, so I never remember. All right, so the next thing is we're going to be using the change of base formula in your calculator to evaluate the logarithm. So the catch is, obviously, well, most of you, your calculator allows you to do log base on your calculator. You need to actually show on your paper the change of base formula, okay, before you type it in. If I don't see the change of base formula written on a quiz or a test, it will just be wrong because I will assume that you did not follow instructions, okay? So 24 is log base 5 of 19. So those of you that don't have log base, this is how you have to type it in using your calculator. So change of base says that we rewrite it. They did not specify what base we have to use, which is nice. Sometimes they do. These ones just say to use change of base formula. I always go common log when I'm going to do it, but it does not matter. If you use common log, natural log, make up a base, you're going to get the same answer either way. So it's log of the big number over log of the little number. So log of 19 over log of 5. And then that's what you would type in. So that way you can just use the log button instead of using log base. So this is the key part that I am looking for when I'm grading quizzes and tests if I tell you to use the change of base formula. Okay, so make sure you don't forget that or you won't get all the points. And somebody can tell me what that is.
1.8.
In 2 decimal places is good, so people often ask. The book goes to 4 decimal places. I think that's a little excessive, so 2, 3, something more than 1. I don't really care. 26. Log base, whoa, that was weirdo. Log base 12 of 259. So how would I rewrite this using the change base formula?
Log of 259 over log of 12.
Somebody can tell me what that equals.
2.24.
All right, these ones did not specify what you needed to use. We could have used ln, we would have gotten the same thing. The next set says to rewrite the expression using only natural logarithm. So these wanted you to get to a final answer. The next ones are going to have a variable in them, so you're just rewriting them. But they want the natural log. So 30 log base 7 of x. How would I write that using natural logs with change base?
ln x over ln 7.
Ln x over ln 7. I think sometimes people mix up what we were doing earlier where we're combining logs with this stuff. So remember, when you are combining things into a single log, you can only have the log written one time. Okay? When we're expanding, we have multiple logs. Change of base is its own thing altogether. I think that's where people get confused on how many logs they're supposed to write or whatever. So these ones just want you to rewrite them using the change of base. There's nothing farther that we can do with that other than what we have right here. 32, we have log base 5 of c minus d. So this one, even though they've thrown some other stuff in here, would just be the ln of c minus d over the ln of 5. And then the last ones are doing the same thing, but using a common log. So I'm probably only going to do one of those because we already did those ones up there. But if you had the common log, so like 30, never mind, that one's weird. 34, log base 4 of x. And I was going to rewrite this with common logs. It would just be log of x over log of 4, like that. So, any questions on any of that? Nothing? All right. Then, I need to see something. Okay. Making sure this was going to work out. Your problems are 1 through 33, every other odd. And when you're done with that, you can do your notes for the next section, but you need to finish this first.